All right, properties of exponents. Again, this is more of an application with the problems and understanding one way of writing something as another way of writing something. Not as much as calculating, however, some of you are going to calculate to see if they are the same. I know that 1 over 4 times 1 over 4 times 1 over 4 is the same as 1 over 4 to the third power, or that would also be the same as 1 over 4 to the third power. I also know from this one here, the way that's written, I could say that this is the same as 4 to the negative third power. Because remember, if it's a negative exponent, you go 1 over, if it's a whole number, you go 1 over, you do the reciprocal, and it's to a positive exponent. So as I take a look over here, you know, the other thing that you should probably do, or I should also talk about, and that is that this answer, when I multiply it all out, is 1 over 64. So there's two ways of doing this type of problem. You can either figure out which of these possible answers is equal to 1 over 64, or knowing the rules, knowing that you can go from this form to that form to that form and so forth, that but either way. So 4 to the negative 3, I already have that written over there on the left, so I know that one's good. 1 over 4 to the third power, I also have that to the left, so I know that one is good. 1 over 4 to the third power is my second one, it's my middle one. And then 4 to the positive 3 power would be wrong. So those other three, notice they're all equivalent. And as you work on these, hopefully you figure out these properties so that you can apply them as well. Let's move on to the next problem. Here it says we want to write the answer in the form of x to the y. Now, some of you are going to say, Mr. Altobelli, the bases are different. I have to have two separate things. Normally I would say yes. However, if the bases are to the same exponent like we have in this problem, we can actually multiply the bases and keep the exponent the same. So I can go 7 times 2 is 14, and I could say that this is 14 to the negative third power. Because of that, going back to my original problem, and now this is to the fourth power. So now I have a power to a power, so that is going to be 14 to the negative 12, and that is going to be the answer. Again, this part here, because it's a negative 3 power and a negative 3 power, those are the same. I can multiply the bases as long as I keep it a negative 3. Then, after I do that, then I go back and do it to the fourth power. And when we're power to a power, we multiply exponents. Okay, here, this one, some of you I've helped on a problem very similar to this, but 6 to the third is 216 if I did my math right. 6 squared is 36. 6 to the first is 6. Remember, any number to the 0 power is 1. Excuse me. The most common wrong answer there is for people to put 0. Okay? But if you think about it, or if you're looking ahead, I have to divide 216 by 6. Ooh. I have to divide 216 by 6 to get 36, and then I divide by 6 again to get 6, and I divide by 6 again to get 1. So it has to be 1, not 0. Mathematics is patterns, okay? Then 6 to the negative 1, remember, a to the negative n is equal to 1 over a to the nth power. So 6 to the negative 1 is 1 over 6. And then 6 over negative 2 is 1 over 36. And then 6 to the negative 3 is 1 over 216. If 6 times 6 is 36 times 6 is 216. All right, so then it says decreasing the exponent by 1 is the same as dividing by 6. Okay, each time we divide it by 6. Okay, let's take a look at another one. Here, the bases are different. The exponents are the same. Because of that, I can multiply my 5 and 3, my 5 and my 3 to get 15. I keep it to the same exponent, which in both problems was 3. This is 3, this is 3. And then now that is going to be to the negative 6th power. And remember, that is equal to 15 to the 3 times negative 6. To the power to a power, I multiply exponents. That will equal 15 to the negative 18th power. All right, let's move on. Here we have one of those again. Notice that this is the same as 1 over a negative 8 to the 3rd power. I am multiplying using this negative each time, so the negative has to be inside. The result, though, the final answer result is going to be 1 over a large number, 64 times 8. Is that 512? We did it earlier in a different video. But this would be equal to, then if I multiply it out, 1 over 512, and the result would be negative. So it would be a negative 1 over 512. Also, from this one, I can say that that's the same as a negative 8 to the negative 3rd power. Negative 8 has to be there, and then the negative 3rd power. I just wrote down this method right here. The second one there, they have it written as a negative 1/8 to the 3rd power. That answer is going to be negative, and then 1/8 to the 3rd power is going to be 1 over 512. So this gives you that same result. It couldn't be rewritten in that form, but it does give you the same result. It asks which is it equivalent to. So yes, that would work. My second one here, some of you might say that these are the same. Some of you would say, oh no, they're not the same. Well, the results would be the same. A negative 1/8 times a negative 1/8 times a negative 1/8 is very similar. It's the same result of what you would have there. So that is going to be as well. And then the last one, 8 to the negative 3rd. 8 to the negative 3rd is equal to 1 over 8 to the 3rd. That is not the same as what I have above. It would give me a final answer of 1 over 512, a positive 1 over 512. So that one is not part of our solution. Moving on. Next one. That is it. Good luck.